We have higher order derivatives as the next section. So when differentiation goes beyond the first derivative, we call it a higher derivative. So higher order or multiple derivative would be what it's called. It just means taking the derivative of a derivative. Sounds complicated, but once you can do a first derivative, you can really do any number of derivatives. So if your function starts off with a y equals, the first derivative is y prime, the second derivative we would call y double prime, the third derivative would be labeled y triple prime, and then beyond that, we would just do a superscript number up top. So we'd do y with a little 7 in parentheses up top would mean the seventh derivative. If you start with a function f of x instead, the first derivative would be f prime of x, what we're used to. But now we can take a second derivative, label it f double prime of x. A third derivative would be f triple prime of x. And then anything beyond that, instead of having to count those primes, we would just do a little number up top. So f with a 4 and superscript up top would be the fourth derivative. Our last notation, which we're going to use in a couple sections, if we start with a y, the first derivative could be labeled dy dx, the derivative of y with respect to x. The second derivative would be the second derivative of y with respect to x twice. The third derivative would be the derivative 3 times of y with respect to x 3 times. And then for any number, we would just put it up top, the nth derivative of y with respect to x n times. Not as common of a notation, but just in case something asks you for d4 of y dx to the 4, I don't want you to think you can't do it. That just means take the fourth derivative. So let's practice this. Let's find the sixth derivative, which is very high of a derivative to take, much higher order than a first derivative of this function here. And we're going to see that it's really not too difficult. So we're going to take the derivative of a derivative. So our first derivative of y, we'll label it y prime. We're just going to bring down the power. We have 7x to the 6. Next one, 2 times 6 is 12. X to the 5th. Then we have 3 times 2 is 6x. Derivative of negative 4x is negative 4. There's our first derivative. We're good to go with that. Now we're going to find our second derivative. Until we get to the sixth derivative, we're going to keep taking the derivative. So bring down the power again. 7 times 6 is 42. X to the 5th. Bring down the power. 12 times 5 is 60. X to the 4th. Derivative of 6x is 6. Derivative of negative 4 is 0. It's a constant. So there's our first derivative, our second derivative. Now we can take our third derivative, which is going to be taking the derivative of our second derivative. So we're going to bring down the power. We're going to do 42 times 5. You might need a calculator. That's fine. We're going to do 210. X to the 4th. 60 times 4 is 240. X to the 3rd. Derivative of 6 is just 0. So it's kind of nice. Each derivative, it seems like we're getting some fewer terms, which is pretty nice to have happen. We're going to keep taking the derivative, though. We can't stop until we get to the sixth derivative because that's what it asks us for. But now that we have the fourth derivative, I'm just going to use a 4 instead of doing all those primes. I'm going to bring down the power. 210 times 4 is going to give me 840. X to the 3rd. Bring down the power. 240 times 3 is going to give me 720. X squared. I'm almost there. I'm at the fourth derivative, but we need the sixth derivative. So I'm going to take the derivative of the fourth derivative, and that's going to give me the fifth derivative. So bringing down the power once again, 840 times 3 is going to give me 2520. X squared. Bring down the power. 720 times 2 is going to give me 1440. And that's just going to be x to the first. So we are doing pretty good. We are ready for the last derivative to take. We were asked for the sixth derivative, so this is where I'm going to finally be able to stop. I'm going to call it y and then have a 6 in superscript. We're going to bring down the power. 2520 times 2 is going to give me 5040 x, and the derivative of 1440x is just 1440. And now I'm finally done. I have the sixth derivative of that function.